Hi everyone, welcome back. Today we are going to talk about another important concept under fuel, that is synthesis of synthetic petrol from coal. In the last class I focused about classification as well calorific value of fuels. Basically the fuels are basically classified into two important classes. One is primary fuel and the secondary fuel. Primary fuel is nothing but it's a kind of fuel which is derived from the nature itself. The secondary fuel is nothing but it is kind of a modified products. For an example, if you take a primary fuel, it could be classified based on the physical state of the fuels. Accordingly, they are called as solid, liquid and gaseous fuel. And when you take a solid fuel, coal is the best example for the solid fuel, and petroleum is the best example for liquid fuel, and natural gas is the representative example for gaseous fuel. Where in the case of secondary fuel, we are going to convert the primary fuel into secondary fuel by doing some chemical reactions. Now let us see the synthesis of petrol or gasoline from the primary fuel. So under this topic, I am going to talk about synthesis of synthetic petrol by following the method is called Berkey's process. So first of all, I would like to discuss about the chemical characteristics of coal and petroleum products like diesel and petrol. So if you take coal, when you analyze the coal, in the last class I focused about analysis of coal. So depending upon the data required, we can go for two type of analysis. One is called proximate analysis and second one will be ultimate analysis. So if you go for the proximate analysis, it tells about the physical matter which is available in the coal component, and if you go for ultimate analysis, it tells about the percentage of chemical constituents like carbon, hydrogen and sulfur and nitrogen and other elements which are present in the coal component. So based on this, if you analyze the coal found to have about 80% of carbon and about 4% of nitrogen, and the rest are going to be other elements like sulfur and other compounds. And if you take the petroleum products like petrol or diesel, it found to have about 80% of carbon and 18% of the hydrogen compounds. So therefore, when you compare the coal and petrol or diesel, the coal is found to have less amount of hydrogen contents. So basically, the calorific value of fuel also depends upon the percentage of hydrogen present in it. In fact, the major contributor is carbon, but the presence of hydrogen also will contribute little bit to the calorific value for the particular fuel. So in the last class itself, I told you about calorific value. So calorific value is nothing but when the unit gram, for an example, when unit quantity of coal is subject to the combustion process, it will give about some amount of heat energy. So that amount of heat energy is called as calorific value. So as I told you earlier, coal found to have only 4% of nitrogen, and petrol and diesel found to have 18% of hydrogen compound. So therefore, coal is said to be a hydrogen deficient material. So in this synthetic petrol production, we are going to convert the coal into gasoline, that to hydrogen rich gasoline, by doing some chemical reactions. Well, so this is the typical experimental setup will be used for the synthesis of synthetic petrol from the coal component. So it consists of the following components. This is chamber 1 and this is going to be chamber 2 and this is chamber 3 and 4 and 5. So the chamber 1 is a kind of area where powdered form of coal, catalyst and heavy oil are mixed together to convert it into paste form. So why we need to do this process? So as I told you earlier, coal is nothing but a kind of hydrogen deficient material. Now we are going to do some chemical reactions, that to hydrogenation process. So for the hydrogenation process, we have to add the coal along with the hydrogen gas along with some catalyst, because as such we can't able to do the hydrogenation process. If we want to carry out the hydrogenation process, we have to introduce some catalyst. So the appropriate catalyst used for this process is going to be either tin we can use, or we can go for nickel oleate. So these are two catalysts can be used to synthesize synthetic petrol from the coal compound. Alright, so this is called the reduction process. Whenever hydrogenation process is taking on the coal component or any hydrocarbon, that's process called as reduction process. And the second one will be a converter, where the catalyst will employ over here. Now the catalytic reaction will be taking over in this second chamber. Now the hydrogenation process will be carried out in this compartment. This is called converter. And the third one is going to be condensation process, because we are going to heat the mixture to the elevated temperature. So while you doing the mixing process and the heating process, now the crude oil. So the material we are getting from this converter is called as crude oil. Now the crude oil will goes to this area, condensing area. Now it will be converted into condensation process, and the crude oil coming out from the condensation chamber will be available in the room temperature. After that, the room temperature crude oil will be subject to the fractionation process. Now, depending upon the boiling point of the particular fuel material like gasoline, middle oil and heavy oil, it can be separated in the appropriate manner. So at lower temperature we will get heavy oil, and middle oil in the middle of the temperature, in middle area we will get the middle oil, and in the elevated temperature we used to get gasoline. So basically in fact the gasoline will have a low boiling point. Even the minimum temperature itself it get vaporized, and it will it will be used for various purposes. Alright, now I will be telling about the operation process. So if we want to get the synthetic petrol from the coal, so we have to take the purest form of coal. So basically there are 4 type of coals we can take, like depending upon the carbon content present on it, it can be classified like peat, bituminous, anthracite and lignite. In fact peat is the one of the impure form of coal, and bituminous compared to peat is okay, and lignite is other one. Normally we use this bituminous for power generation, and anthracite is the pure form of coal, and calorific value of anthracite is found to be about 6,000 to 8,500. So if you use such kind of coal for synthetic petrol production, we can get maximum amount of output in the time of gasoline. Alright, so once you take this anthracite coal, that has to be subjected to the powdering process. So we have to crush the material, and it has to be poured into this compartment, and once you add this coal component, it has to be mixed with heavy oil, so which is having high molecular weight. So the high molecular weight oil is mixed with the coal compound, and after mixing this process, we have to introduce the catalyst material like tin or nickel olate we can use. Even nickel oxalate can also be used as a catalyst. So if you mix the catalyst along with this, it will be converted into corresponding paste form. Now the paste is with the help of mechanical pump, it will be subject to the it will be pressurized into the second chamber, and during the journey it will be mixed with the hydrogenation also. So here we are going to add hydrogen molecule in the form of hydrogen gas. We are going to pass the hydrogen gas through this paste, coal, heavy oil and catalytic mixture, and once you add this hydrogen gas in this area, in the chamber 2, now the hydrogenation will be taking place. So due to the presence of this kind of catalyst, so it will start the reduction process. Reduction process will be taking over here. So your reduction will be taking place. Once the coal is get reduced, that means we are going to add hydrogen molecule along with the coal compound. Now once the reduction process gets completed, now it will be converted into the gaseous form. The gaseous form of this hydrogenated material will reach the condensing area, where it will where we have the cold water supply. So this is cold water supply is available over here. Cold water supply. So due to lower temperature, the gaseous form of molecule gets condensed, and once it condenses, it will be converted as a crude oil. So now the crude oil will be allowed to send to the distillation chamber. That too, not distillation chamber, it's a fractional distillating column. So here we are going to raise the temperature with reference to the type of component which is available on it. So depending upon the boiling point of the liquid, the different amount as well different type of hydrocarbons we are going to get it. So one will be hydrogen rich gasoline material, and another will be hydrogen less material, and third will be heavy oil. So the heavy initially we have used the heavy oil. So once we separate the heavy oil again will be passed through the pasting chamber, and it will be recycled again and again. So we can use this heavy oil for prolonged time by doing the recycling process. So once you get the gasoline from this chamber, the output is once you get the gasoline chamber, it is used for various destination purpose, or it can be stored and it will be transferred to some other area. And along with the equal amount of gasoline initially, we used to get middle oil also. So when you look at the chemical composition of middle oil, it will have enough amount of carbon, but it will have very less amount of hydrogen content. So in fact, it's a pure form of middle oil, but it will have very less amount of hydrogen. So therefore, again we have to do the reduction process, and for this reduction process we are going to add hydrogen along with this middle oil in the presence of catalyst again. So once you add this hydrogen along with this middle oil in the presence of catalyst, again reduction process will be taking place and it will be converted into corresponding gasoline. And when you look at the output of this process, it used to give us about 65% of gasoline, which means if you take 100 grams of coal, for the conversion process, we used to get 65% of gasoline from this process. So this is one of the important process which can be used for synthesis of synthetic petrol from coal components. And what are the advantages? So basically, when you look at the utilization of various fossil fuels, in fact our 95% of our requirement, 95% of our energy requirement is fulfilled only by the non-renewable energy resources. Non-renewable energy resources, which include like coal and petroleum products, which include petrol and diesel. And such kind of fossil fuel can be used for, and coal is mainly used for producing electricity in the thermal power plants, and petrol and diesel used for operation of IC engines and transportation purpose. In fact, this is also used for generating electricity. And when you look at the utilization rate or the demand, its demand is much more higher. So therefore, we are not able to meet the requirement of diesel and petrol material. So therefore, we are in a position to convert coal into synthetic petrol. So the conversion process can be done by the help of Birki's process. So we can able to meet our day-to-day requirement by doing this process. So this is the utilization rate about the synthetic. This is all about the utilization of non-renewable energy resources. In fact, if you use such kind of, I will tell about little bit about the environmental consequences of usage of these kind of fuels. So basically, both coal and petroleum products like petrol and diesel used to emit when these fuels are subject to the combustion process, they used to emit much amount of carbon oxides like carbon dioxide, carbon monoxide, and a little bit of sulfur oxides too, like sulfur dioxide and nitrogen oxides. So if you use such kind of fuel in the IC engines or thermal power plants, they used to add these kind of gaseous components into the atmosphere, and these are called as pollutants, because CO, carbon monoxide and carbon dioxide is highly contributing to the global warming process. So global warming is, even in the last class itself I was focused about this global warming process, is nothing but rising the temperature of the globe due to the presence of such gases, because it used to trap the radiations and keep the earth as the warm element. And when you look at these two pollutants like sulfur and nitrogen oxides, they used to cause, basically these kind of oxides were normally less stable in nature. When it allowed these gases in the atmosphere conditions, they will take a long journey in the atmosphere and it forms a corresponding stable oxides like sulfur oxides and nitrogen oxides, and these oxides will react with the water molecule which is available in the atmosphere, and it will be converted into corresponding powerful acids like HNO3 and sulfuric acid H2 SO4. So such kind of acids will get mingled with water molecule during the precipitation process, maybe during rainfall or snowfall, and will reach the earth component. So that's called acid rain process. So this is one of the undesirable process. This is called climate. This is due to climate change effect, climate change phenomena. So therefore, we will as conclusion, we will try to minimize the utilization of fossil fuels like coal and petroleum product, and we will try to utilize the renewable resources like solar energy, solar, wind, and tidal energy, even geothermal energy as maximum as possible. It doesn't mean that we are supposed to stop the usage of fossil fuel. It is well known that we should use the resources only in the judicious manner. So that is called sustainable development. So sustainable development is nothing but meeting the needs of the present without affecting the future generation needs. So because We all know that this is one of the non-renewable resources. No longer we can get this kind of material from the earth crust. So we have to use the resources only in the judicious manner, and we supposed to hand over healthy and safe resourceable environment to our future generation needs. So therefore we have to be very careful while you using these kind of non-renewable energy resources. So I just want to summarize it again. So as I told you earlier, synthetic petrol can be synthesized with the help of Berkey's process from coal. The conversion process is called as synthesis of synthetic petrol from coal. That is called the hydrogenation process, and it can be done with the help of middle oil. It can be done with the help of heavy oil and kind of catalyst like nickel and tin based catalyst material. So when the coal is subjected to the kind of reduction process, some reduction reaction will be taking place. So hydrogenation will be carried out, and the hydrogenated oil will be sent to the condenser, where the condenser will condense the gaseous components into crude oil. Now the crude oil will be subject to the fractional distillation process. So depending upon the boiling point of the liquid fuel like gasoline, middle oil and heavy oil will get mixture of elements, and at lower temperature itself the gas will get vaporized, so we can easily separate it out. And the next one is going to be middle oil, where the temperature, the boiling point will be much more higher than the gasoline material, and will get once you elevate the temperature to that boiling point of the middle oil, you can separate the middle oil easily. But the middle oil found to have less amount of hydrogen content, so therefore again we have to do this reduction process by applying hydrogen on it. And thirdly, we can get the pure form of heavy oil. Now the heavy oil will be subjected to the again cyclic process, hydrogenation and mixed with coal, and reduction process will be carried out. This will be taking place in the endless cyclic manner. So this is called the synthesis of synthetic petrol from coal component. Thank you.